calculator? Yes. And so after seeing the, what's the word, the messy way of doing it, the big way, the long way, I'm trying to think of other verbs for the proper way of doing it. Let's show you how to do it now using your calculator. We're going to do hypothesis testing, which is weird. There are going to be two versions. Sigma known. The second version is going to be sigma unknown. Okay. So I'm going to create a story of each of these and show you how the calculator can be used to do the whole thing for you, right? Now, within these two versions, there's going to be ones where you just use statistics, like X bar, and there's others where you'll use data, where you basically get a list of numbers. And for this one, there's two versions as well, statistics and data. Okay, and it's all going to ham here. It doesn't mean that you don't have some work to do, you will, but you'll certainly have a lot less. So here's my first story. We have an old drug, and in this old drug, when someone takes it, the average cesium level ends up being 45. And this chemical company has got a new drug. And, oops, I shouldn't have called it that. Call it new equals 45. This second company, right, has a new drug. And they did a sample of 100 people. And this new drug increased the cesium level to 47. So, you know how some drugs keep your cholesterol down and some drugs, I guess, put your cholesterol up? Because I guess some people have an illness where they don't have enough cholesterol. I'm assuming the way the body works, you get both sides of the coin, right? Some people have high blood pressure, so you want to reduce it. Some people have low blood pressure, you want to increase it, right? So we've got this comparison. We want to know then, is there enough evidence to show that the new drug is doing a better job, is increasing the level? Because this is basically the average level that an adult might have. And we need the significance level. And since this is to do with drugs, I'm going to err on the side of I'm going to be right 99% of the time. Or I'm willing to be wrong 1% of the time, which is the same thing, right? So in this question, you're also told that sigma was 1.2. Actually, let's make it a little bit more interesting. You were also told that sigma was 7.2. That's a large number. So I'm assuming then that there's an awful lot of variation in this level, right? People who take this drug does a really good job. Other people take it, it's not so good, right? It doesn't affect them. Let's set up our hypothesis test. That you have to do. And we're assuming that that's in the past. And don't we want to see if there's evidence to prove that it's got bigger? And we're going to have a significance level of that guy. Well, at this point in time, wouldn't we have to do all that standard error, z-score, calculate the p-value, right? All those number crunching stuffs. We're going to get that all done on the calculator. So, anybody got a guess where it might be? Where do you think they might be hiding this hypothesis test thing?
Is it under tests in stats?
Yep. So hit stats, and I think it's kind of sensible you put it under a thing called tests, right? So I guess I'll put a little right, so you can see it, right? Now you need to know which one it is, because this particular menu, isn't this particular menu got a lot of different things in it that we use for a lot of different situations, right? The guy that you want is sigma known. Well, I wish it had said test sigma known, but it's Z test, it's number 1. So choose number 1, Z test. Okay, so that's my little cryptic thing. So let's see what happens when I hit that. Do you see that there's choices? Either you put in statistics or you put in data. Do you see why my little menu went 2 ways? Because there's 2 kind of flavors to this question. In this case, weren't you told just the statistics? Right, you're told these guys. So I'm going to hit that, right, and use it. And mu naught is that guy. So we type in 45. Sigma, obviously, is that guy. X bar, 47. Sample size, 100. Now, do you see that it gives you a choice of less than, greater than, not equal to? Aren't we looking for greater than 45? So if I go to this one, do you see the guy at the end is greater than 45? If I move this down a bit, you see that guy there represents greater than mu naught, which is 45. And then you hit calculate. And you get all those numbers. Do you see the Z score is 2.778? They're calling it P, but I call it P value to make it understandable, is 0.0027. And the other stuff I knew anyway, right?
I must have input it wrong on mine.
Okay, let's try it again. Hit stats. Go over to tests. Number 1. Make sure it's number 1. Hit enter. If it's highlighted on stats, as it is here, move down and make that guy 45. Not the X bar, this guy, 45. Then make the next guy 7.2. Make X bar 47. 100. Choose the option to the right hand side because we're looking for a greater than story. And then move to calculate and hit enter. You're now seeing the numbers?
Yes, sir.
Right, so, okay, we fixed it. Now, can you imagine how much work it is to get those guys yesterday? Do you see how much easier it is now? So that's kind of step 1. That's kind of step 2 and 3 all done for us, right? Isn't the last step conclusion? That we still work with, right? Now, in conclusion, we check, is the p-value less than alpha? So in this case, it's 0.0027. Is it less than 0.01? Would you agree in this case the answer is yes, it is? Would you agree that is less than that? So conclusion. Isn't this statistically significant? Right? So this is statistically significant. If you ever get to say yes, that means it. And you'll see that phrase sometimes mentioned. You ever heard them talking about they've got a statistically significant result here? Something that is agreed by the community, the science community, as representing true evidence. In this case, what have we proved? Well, we've proved that, this is the jargon sentence, that we can reject H naught, and so the alternate is true.
And I have a question.
Yes.
I don't remember from yesterday I was struggling a little bit with the homework about, is this statistically significant? And
Yes.
I guess I don't know how to tell. I can tell that it's yes, but I don't know how do I tell that it's statistically significant or not?
Oh, dead easy. If the answer is yes, it's statistically significant. If the answer is no, it's not statistically significant. So that's an easy fix, right? If you can say yes to this, it's statistically significant. If you end up saying no to this, it's not statistically significant. What we've proved here, and essentially it's like a court case, we've proved the guy guilty. What we've proved here is that that new drug is in fact better at doing its job than the old drug, right? So you could put that as an advertisement. You know, when people advertise a new pharmaceutical drug, don't they say it reduces this much better than the old drug does, right? Or it increases this much better, or you'll live longer if you take this drug, if it's some cancer treatment, right? Whatever it is, those statements can't really be justified unless you have done a hypothesis test on them and compared it against whatever you're calling the generic drug that your comparison is to. And this process is part of the FDA's process of checking, is a new drug or treatment going to reach the big market? Is it going to be allowed to be given to Americans as part of their treatment regime? The best way to do this would obviously be a double-blind experiment, right? Where you would get maybe a couple of hundred people and give them the old drug, a couple of hundred people give them the new drug. Nobody knows which drug they're getting. Doctors don't know which drug they're getting, and then you collect data on one and compare it to the other, right? That would be the ultimate way of doing this. But this is a cheaper way, because isn't this data probably already known? Because the old drug's been out there for a while, so pretty much they know what it is. That means you can reduce your costs, because don't you only need to do half the number of people to get the same effect, you know, the same proof.
I have a couple questions.
Say again?
I have a couple questions.
Oh.
First, could you also say it's statistically significant at 1%, meaning that 1% of the time you might be wrong?
You could add that number. Very often when the number that they add isn't the alpha, the significance level, because that kind of throws people if you say it's statistically significant at the 1% level, because people who don't know statistics read that badly. They read that as, oh, you mean that you're only 1% sure that it's true? When actually, when it's 1% significant, isn't it 99% sure? Right? And what you tend to actually do, if they do it at all, and it's really only for scientific people who would do that, you would give the p-value. You would say it's statistically significant with a p-value of this, because this p-value is a reflection on the probability that what you saw was coincidence, was chance. So can you imagine in this case, this would be what, about 0.3%? So you're saying, I'm that confident that this is statistically significant that there's only a 0.3 chance that I got it wrong. And that's a powerful number, because this tells you a little bit more than that. Couldn't I have had alpha at 10%? And if I said it's statistically significant at the 10% level, right? It would have been true. I'm going to have to cancel this a little bit for a second. Get rid of that noise. So it would have been true to say that, but would you agree that it's probably not giving you a clearer picture? So we normally just say statistically significant, but if you go and you delve into, say, a report in the Lancet or so on, that information, the p-value and the z-score, will almost certainly be there. And if it's not, people would complain. Because if you're a doctor and you're reading about a new medication, don't you want to know how many people the trial was done with? I know it's significant, but I'd like to know, for want of a better word, how significant, right? See if the p-value is 0.098. Couldn't that be significant at an alpha of 10%? I wouldn't feel so comfortable about that, especially with a pharmaceutical, because doesn't that mean 1 in 10 chance that this drug isn't actually doing any good or any better than the old drug was? So pharmaceuticals in general, anything that's life-threatening should really use the smallest alpha you can get away with. That would just be common sense, I think. Now, I promised
I have a
you
question.
yes.
I'm sorry. So is it always statistically significant if the p-value ends up being less than the significance level?
Yes.
Okay. That's what I just want to make sure.
I like
was
short
understanding
answers
correctly.
like yes. It's much easier than saying yes in this circumstance, but no in this other circumstance. And then you have that problem of, well, what happens if
Right.
there's a third circumstance? Where do I go? It's much cleaner, isn't it, when if this is true and you say yes, it's statistically significant.
Right. Thank you
Very
so much,
clean.
Professor.
You're welcome.
And then one more thing. Is the sigma 7.2 from the original population?
Yes.
Not the sampling.
Yeah, it's from the people who took the old drug.
Okay. Oh, okay. So it would go with the mu of 45.
Yeah,
Okay.
it probably should be written there. In fact,
Oh, okay. That makes sense.
when you see the story written, very often this information is on the same sentence, and then this stuff happens later. Now we've looked at situation 1, where we know sigma, and we were given a statistic. So situation 2 is I'm going to do another story, but this time sigma is still known, but we're going to give you the information in the form of some data, right? So here we go. In the past, university basketball players used to have an average height of 69 inches. And that the standard deviation was 3 inches. And a social scientist thinks that basketball players at university now are taller than they used to be. So he decides to do a little experiment, a little hypothesis test, to see whether or not he can come up with some statistical evidence to prove that. So what he did is he randomly selected 8 basketball players, right, that are at college, and he got their heights. And I'm making this up, but one of them was 68 inches, one of them was 71, 69, 73, 75, 76, 1, 2, 3, 4, 5, 6. Okay, let's just say it was 6 people, right? So he got a very small sample of 6 people. So that's basically data, isn't it? And he wants to see, is there enough evidence to prove that basketball players today are taller than they used to be in the past? So we're going to have an H0 and an HA. Right, so based on what my story was, is there enough evidence to prove that basketball players of today are taller than the past? Let's see what the hypothesis test looks like. Let's begin with, what would H0 look like? Mu
He's 69.
equals 69, right? Now, since I'm interested in proving that the basketball players of today are taller, wouldn't that make this guy, is there enough evidence to prove that it's greater than 69? Great. Right, are they taller? Now, you might say, wait a minute, that person's shorter and that person's 69, which I agree. But aren't these 3 people taller, so it does look like it might be true? No guarantees. very small sample size, but you know, we'll live with it. Is this called left-tailed, right-tailed, or two-tailed test?
Is it right tail?
Correct. Pointing to the right, right-tailed. Right, time for calculator. Okay, so clear that out of the way. I'm going to go into start. I'm going into edit, and I'll clear this one out of the way. And I need to put my data in. So I just go 68, 69, 73, 75, 76.
You
You
missed
okay with that? Yes.
You missed 71.
Thank you. Easy fix. Glad you got it. Right? Yeah, if you miss one, can't you just tag it at the end? Because the data doesn't need to be in order. Calculator's happy with it, any order you like. Now, hit start. Go over to tests. Since sigma is known, doesn't that mean we use number 1? If you know sigma, you use a Z guy, right? If you know sigma, you use a Z guy. So hit enter. This time, I'm going to use the data choice because it's not X bar, right? Isn't it just a whole load of numbers? It's data. Let's see what that looks like. Okay, so we got that guy sorted out. New note is 69. Sigma was 3. The list was L1 and frequency is 1. Right, we're good with that. If I now go, I'm looking for greater than 69, aren't I, this time again? Greater than 69, just make sure. And then when I hit calculate, won't I have all the good guys that I need, all the P's and Z scores that I need? And maybe some other stuff. So in that question, I've got a Z score of 2.45 roughly, and I have a p-value. Oh, that is weird. Isn't that the same p-value I got for a totally different story with totally different numbers? Whoa. What's the chances that that would happen? That's a Z score away up in the 5s and weird places like that. Isn't that a like? If I tried to do that a third time, totally randomly, wouldn't it be a miracle if I got the same kind of number? So there is no reason why the p-value should ever be the same in every question, right? That's kind of obvious statement, but I'm saying it now anyway. Okay, so we are on to our conclusion, aren't we? And I forgot my story, and let's say he's using a 10%. Right, that would be part of the story, right? Significance level of 10%. So conclusion, is our p-value less than alpha? Is 0.007 less than 0.1? I think that's a very emphatic yes, isn't it? Is this a statistically significant result? In the jargon of hypothesis testing, don't we have a sentence that goes along something like this? I think I forgot to put in there is enough evidence the first time, but that's part of the sentence. So there's enough evidence to reject H naught, and so HA is true.
One more question.
Yes.
When you're doing the conclusion, p-value is less than alpha.
Mm-hmm.
Is that ever greater than alpha, or is it always?
Oh yeah, it will be sometimes. I haven't done one yet, but I can. There will be a. Oh, The conclusion is always based on this question, if that's what you're asking. It's
I guess
always
that's
less
what
than.
I'm asking.
Yeah, it doesn't matter what way that points. It's always that.
Okay.
What I thought you said, so I'll answer a second question, is can you imagine that sometimes the p-value is going to be quite big? It's going to be 0.3 or something. In those cases, don't you get a no? Which means it's not statistically significant. Now, in English here, couldn't that guy say it's statistically significant evidence to prove that basketball players of today are taller than they were in the past? So we've managed to prove something. We cool?
I have a question.
Yes.
If this problem was in an article, would it be wise not to trust the results because of the sample size is so small?
Oh God, for sure, yes.
Okay, because I was getting
This is
confused
the hypothesis
'cause we're saying it-
process. Yeah.
Okay.
This is hypothesis process, but there's a thing called common sense, which basically says nobody would really give this a lot of credence based on the fact that a sample size of 6 is so small. Now, if you were an unscrupulous person, wouldn't you just not mention any of the details like sample size? And
Is
wouldn't
that
that
Oh, go ahead. Sorry.
and that would make people who weren't who didn't understand the background to these kind of questions, wouldn't that make them think it was really important thing they've just discovered? There is a lot of very bad COVID analysis going on right now. I saw one, I think, in the newspaper yesterday. Now, they kind of covered their butts a little bit and said it was a small sample, but they kind of said it in a way like it wasn't that important. But it was a tiny sample. I can't remember the number. It was like 60 people. And they were looking at people who had COVID and the side effects that they had after they'd recovered. And from this 60 people, 7 of them said that at least during the COVID, they had issues with hearing, which isn't, to me, it was one of those articles to scare you. Well, do you know when I get a cold, my hearing is affected? 2 of the people said that it had given them what they believed to be long-lasting hearing issues. In other words, they couldn't hear quite as well as they did in the past. Now, if you think about 2 out of 60 people who says that, there's a lot of subjectivity in that. First, it's tiny, 60. Second is, do you know we're very bad at judging of how good our hearing is? And if you've gone through a bout where you didn't hear very well, you might have a false expectation of what your hearing used to be like before you had the COVID. And so you might, quite honestly, you're not lying to anyone, think that your hearing is a little bit impaired. Like, you know, if you could put a number on it, I'm 5% worse off than I used to be. But the only way you could prove that would be, wouldn't that person have to have a hearing test before COVID? And then another hearing test after COVID? Because subjectivity is very dangerous evidence. I feel weaker than I did before I had the COVID. I feel I get more headaches now than I did before COVID. I think my hearing is less good than before I had COVID. Because there's a lot of subjectivity in all of those things. And from start to finish, that article was to scare you. Because it's going to say, hey guys, you know that if you get COVID, you might go deaf. It was almost kind of that sense of fear that they were generating into you. And when I looked at it, I just looked at it and I said, nobody should have published that. I mean, they just shouldn't have. Now, if they do a really big sample and they get good, reliable data, then I'll listen. I'll say, God, that COVID's a big disease. Not only do you, when you get it, is it horrible and it might kill you, that for some people there's long-lasting effects on their hearing. And you know, I would accept it. But I'm not accepting somebody who did 60 people and only 2 of them said they believed that their hearing was impaired compared to what it was before. It's just bad science. And there's an awful lot of bad science going on right now about COVID. It's all over the place.
So
Right.
I just had a quick question about if for COVID, they're arguing about looking at the proportion to cases versus the proportion to deaths in the population.
Right.
So which one would be, I mean, they were arguing of which, they were saying that the cases, it was going down apparently, but with, deaths overall is that we were, it was increasing, and then compared to other countries, we're like one of the worst. So my question is, which data would be significantly significant, or to what would we be looking at or need to look at?
Yeah. We are in the fog with COVID. We really don't have good data. There is certain data we have that's really good. We know for sure how many people have died of COVID because they're dead. That's kind of easy to count. Now, of the people who died of COVID, what is not so clear is how many did COVID actually was the main cause of death. In some states, when someone dies, they will test for COVID. If you get killed in a motorbike accident and you happen to have COVID, you're a COVID death. In other states, which I would think would be the better way, if you were in a motorbike accident, wasn't your cause of death the motorbike accident and not having COVID? Now, it gets a little bit grayer when you have someone who's extremely ill, someone who is terminal cancer. They got 5 months, 6 months, a year to go. Can't really tell with cancer. Sometimes people with 6 months die tomorrow, and some people last 2 years, right? Terminal cancer, right? They know they can't cure it. It's just make your life as comfortable as you can. If that person catches COVID and dies, is that a COVID death or is that a cancer death?
I would say it'd be both, but
Yeah, but they have to count it as one. And so even the number of people who've died of COVID, we know how many have died with COVID, right? That they're pretty good at testing. But within that subgroup, how many died because of COVID? Right. Now, a lot of the people who die of COVID have other issues. They're very ill sometimes. That'll kill you. COVID's just like the straw that broke the camel's back. That's one group. Some of them have underlying conditions that might not be killing them, right? They could last for years and years and years with it, right? But they get the COVID and that's enough to kill them, right? Do you see that two groups? I think one of them is a COVID death and the other, they probably would have died. If they hadn't caught COVID, they would have died anyway. Who knows when, tomorrow, next week, but they would have died. And so that number is kind of vague. The big number that's really vague is how many people have got COVID or had it. We still don't know that number.
what was that question?
How many people have had COVID, right? And are over it, right? You caught the flu and you're over it, right? I've caught COVID and are over it, or have COVID right now, right? How many are COVID people, right? How many is going to be the bottom number that you stick the deaths on the top, and that way you get the death rate, right?
Give it.
Do you know? The answer is no, we don't. And the reason we don't know it is we know that there's a lot of people who caught COVID, got over it, and never even knew they had it. What we don't know is that a lot of people or just one or two? Now, if it's a lot of people, let's pretend that it's a really large number of people. It's 20 million Americans have actually had the COVID and never knew it and are fine, or had it and got better, right? Now, if you put 20 million in the bottom and you stick the number of deaths on the top, couldn't that death rate be quite small? On the other hand, Maybe only 2 million Americans have had COVID. If you take the same number of deaths, but you stick it over 2 million, can you see that you could have a difference of a factor of 10 in the death rate? We don't know the top number that well. And we definitely don't know the bottom number at all, in my opinion. So people who keep quoting to you death rates, where are they using their numbers? Because they somehow have a magic ball that I don't know about, where they know what the bottom number is, and somehow they know exactly what the top number is. Now, what you can do is you can say, this today, 180 people died of COVID. You can say that, right? Because they're in hospital, they're getting treated, unfortunately they died. That you can say pretty clearly. But what's the bottom number? Do you count the people that are in hospital who have COVID? No, because aren't they the people who needed to be in hospital because they got the bad version of it and their health and life is in danger? Aren't there some people with COVID who were just quarantined at home?
Mm-hmm.
Well, they're a bit better. At least you know that they're healthy enough. That's a bad term, but they're not that serious that they need to be in hospital. You know that one. That's a good number, right? Add them together. But what about the third group? People who've got COVID and don't even know it. Is it? I think it's called asymptomatic.
Mm-hmm. That's what I am. Yeah. Can I
So
say something?
you had it and it's gone and you never
Yes.
even knew it.
And I have 2 kids. I have a daughter. I have 2 1-year-olds right now. My daughter's going to be 1 here next week. 2 next week. My husband didn't get it, and none of my kids got it. And I was, all I had was a little, I had asthma. That's the only thing I had, a symptom of it. And they literally told me to go home, keep myself. I mean, they didn't give me any medicine. They didn't tell me anything to how to treat myself, nothing. And I had it for probably 3 or 4 weeks. I didn't even know about it. All it was a little bit of chest pain and nothing extreme and shortness of breath.
Right.
I had asthma, and that's it.
Right. Huh. Did you ever get counted as a COVID person?
Me?
Yeah.
Yes.
Okay. So you'd be one of the known numbers. Now, I've been told that there's examples of people who didn't even know they had it. Give me an example. My wife caught the cold stroke flu. And it was a weird cold and a weird flu. It wasn't quite like the usual. Now, she might have just had a cold or the flu. She got better. Nothing wrong with her now. This is months ago, way back in the early stages. She could be a COVID-19 asymptomatic person, right?
Mm-hmm.
Now, Jennifer, you weren't hospitalized, so I guess you just get tested because you were worried that you might have it? Or,
yeah, because my husband works in a shipyard. He did take 2 weeks admin leave just because he works in a shipyard. That's
Right.
the only reason I went and got tested. Is because of my young ones and my husband working in the shipyard. It wasn't really for my safety or my concern at all, honestly.
Yeah. So when
Yeah.
you think about it, if your husband hadn't had that opportunity, wouldn't you have just brushed that off as some
Yes.
weird cold flu thing that you had?
Pretty much so.
And you wouldn't have been counted?
Yeah, I wouldn't have even really honestly cared. I mean, it was no big if I would have gotten worse or extreme, or it would have been different, but otherwise, no.
Right. So do you see how hard it is to count those people? Right? Jennifer did get counted, but she might easily not have been counted. How many hundreds or thousands or millions of people in America? That's making a big difference. So the bottom line is that's bad science. Don't pay attention to how many people have been tested and are in hospital. That's a countable number. I'm not a problem with that. People who died with it, cool with that number. The minute they start saying percentage death rate, not interested. I don't think the science is strong enough. Now, if you want that number, you better do a big sample somewhere. Get 100,000 Americans and test every single one of them. Find out your base bottom number, right? How many have had it and got better and never knew it, that kind of group. then I've got my bottom number. We can argue about who died of it, right? Like the motorbike COVID story, but at least I got a good bottom number.
Right. Because
And then I can say the death rate is 10%. God, I hope it never is. I think the guesstimates I've heard are that it's small. If you catch COVID, the chances that you will die with it are quite small. Now, they're big. Well, I'm contradicting myself. A 2% death rate is horrible, right? But it's not the Black Plague. It's not 90% death rate. It's not Ebola, which I think was 99% death rate, right?
Right. I think it's like
in
50%.
perspective.
Yeah.
Right, in perspective. And within that, it's not even the same. 80-year-old person getting COVID has a much higher death rate than a 25-year-old catching COVID. So even within that data, that is good statistic stuff. I like that kind of stuff. But unfortunately, we've got to move on, right?
Sorry about that.
No, that was good stuff. So are we happy about a story where they tell you the mean and you do a hypothesis test, sigma known, and then how you do it if it was a second one? So let's look at situation 2, pardon me, sigma unknown. So, where should we go today? The average wage of a Scotsman in the past for an adult male was £180, right? And a social scientist thinks that Scots people have got heavier. And so we want to find out if there's enough evidence to prove that's the truth. So this was in the past. Now, in this case, sigma is unknown, right? We don't know sigma, right? It's not mentioned in the story. So what we do is we collected a sample of, say, 100 Scotsmen, and we found out that they weighed 182 pounds. And we are going to do a significance level of 1%. So our story now is there enough evidence to prove that Scottish people of today are heavier than they were in the past? So H naught mu is 180. Do you know my next question, I'm going to make it a lesson. I've just realized I keep doing bigger than today. So in this case, it is another greater than, right? Time for calculator. Clear this out. Now I'm going to hit start. I'm going to go over to tests. And I have to choose which one to do. Now I think I said somewhere, if sigma is known, it's a Z, and then the sigma is unknown, it's a T.
T-test.
So number 2, you see how you tell? If you know sigma, it's a Z. If you don't know sigma, it's a T. That's the way to remember. Now I'm going to hit this guy. Now I have the same choices. Is the information data or is the information statistics? Well, in this case, it's statistics, isn't it? And I think I need to tell you another statistic in a minute. So I'm moving over to stats. Oh, and by the way, see this sample that I just did of 100? The standard deviation was 5, right? Now that's the standard deviation of the sample. It's not sigma, right? It's the sample. So let's see what we got here. Mu is 180. X bar was 182. The standard deviation of that sample was 5. There was 100 people in this sample, and we're doing the bigger than, and we're going to do calculate, right? And let's see what we got here. Ooh, we got a p-value of 6.1 times 10 to the negative 5, which is just within the realms of I can write it down. We should have a Z score in there. Oh, it's a T score, but it don't matter. Right. Oh, do you see this has a T score of 4? You see it? I'll just put that down because it's there. But the important guy is basically that guy, isn't it? That's the one that matters. So let's, that's 2 and 3 done. Let's go for conclusion then. Is our p-value less than alpha? Is 0. all those zeros 61 less than 0.01? And the answer is yes. I'm not going to do this anymore because I'm getting tired of writing it. But can't I write this sentence again? Basically the same sentence if it's a yes, right? This is statistically significant. There is enough evidence to reject H0 and so HA is true. What we would be able to say here is there's enough evidence to prove that Scottish people of today are heavier than they were in the past.
But how did you get 5?
How did I get what 5?
Right under the 182. In the first step.
He added that for this. It's the standard.
Oh, this
deviation.
here? Yeah. I added that as what you'd be told in the question.
Okay.
I just gave it to you. You can't calculate it. You just have to be told it. At least in this question, you can't calculate it.
Why is it standard deviation of the sample rather than standard error?
The standard error is calculated inside the calculator. So the standard error would be Sx over the square root of n. So the calculator does that for us. It uses the standard error. We just tell it what the standard deviation is and it figures out what to do from there.
Okay.
I'll give you an example. See, when we do the proportion ones, isn't the standard error the square root of p, 1 minus p over n, right? A version of that. We only tell the calculator who p and n is, and it figures out the rest for us. So it's not that it's not using the standard error. We just don't need to tell it the standard error. We just need to tell it a number that it can use to get it. So in this case here then, statistically significant evidence to prove Scots people are heavier than they were in the past. So I'm going to do a story that has a less than, because we haven't done a less than, right? So I need to figure something that's gone down in the past. Oh, here's one. In the past, before COVID, a small town used to have 20 car accidents a day. Right? Now that could be in fender benders or more serious, but 20 a day, right? A small town had 20 a day. And a person believes that that has gone down. The number of accidents in this town is not 20 per day. It's gone down because of COVID. People work at home, so they don't need to drive to work, right? People don't go out as much, so they're not in the car so much, right? Things like that. In fact, that's true. I'm pretty sure that's true. Have you seen some adverts where insurance companies are giving you money back on your car insurance? Do you know the main reason they're doing that is less cars on the road, less accidents, they're paying out less. So you're being insured against a situation that is less dangerous, right? If you only use your car half as often, isn't there going to be half as many accidents, typically? Right. So this is the fellow that they have. We're going to do a significance level of 0.5%, right? And in this story, what did he do? Well, he collected data from the police. I guess that's the people that you would get car accident information, right? When you have a car accident, don't you have to report it to the police, right? So he goes to the police and he says, I'd like some data on the last 10 days, how many car accidents there were. Right? So this is what the data looked like. It was 17, 19, 18, 18, 21, that was a bad day, 17 and 10, right? So 1, 2, 3, 4, 5, 6, 7. So he found out How many accidents were there last week? Tell me the last 7 days, right? And that's all you need to tell me. And he wants to see if there enough evidence to prove that the number of accidents per day has actually gone down. So the null hypothesis, won't that be mu is 20? We're all comfortable how that guy and where you get the number from. In this case, isn't the alternate going to be that it has gone down? Is that called a left, right, or two-tailed test?
Left tail test.
Right. If he wanted to prove that the number of accidents per day had changed, and he gave no preference to it changed because it got more or less, just that it had changed, wouldn't I write mu not equal to 20 in that story? Right.
And it would be a two-tailed test, right?
And it would become a two-tailed test. You nailed it, exactly. So the language of describing it is helpful, right? Light-tailed, left-tailed, two-tailed. Now, calculator time. Yes, calculator time. Hit stats, go over to calc. Now, oops, second quit, clear. Right, try that again. Go over to calc and test. Since sigma is unknown in this story, in fact, isn't the standard deviation also unknown in this story? There's not an awful lot you know. You know it used to be 20. You know you're using a significance of 0.5, and that there are 7 numbers that you're going to use as your data. Can you see in this case, aren't we going to use number 2, the t-test, right? Because we don't know sigma. And
Sir, I'm sorry, could you pull down the paper a little bit? The top part, I can't see the top part anymore. Sorry.
I help?
No. Yeah, okay, yeah, there we go. Thank you. Sorry
Okay.
about that. Didn't write down.
Right.
fast enough.
I just realized something, which I do frequently in these questions. Don't I need to put the data in first before I go to this menu? So
I was
let's
just going to ask that.
let's do stats edit. Let's go up and clear that data out the way. And let's do 17, 19, 8, oops, I can fix that. 18, 18, 21, 17, 10. What's your gut feeling? Do you think that that's going to be enough to be statistically significant? Don't have a good feel about that. I'm not sure. I'm not that convinced either, but that 10 might help. Because there's only 7 numbers, and that 10 is quite influential because of them. So now I can go down to 2t, and can you see this time I have to use the data choice? It's the same, isn't it? If you only tell me numbers, isn't it the data choice, right? If you tell me statistics, it's a stat choice. So for each of these, there's a 2-choice thing.
Can we easily say that if there's no X bar, then we know it's going to be data?
Yeah, I would say if there's a
our
list of numbers, you know it's going to be data, but
Right,
that's
it's
the way
telling
my
you
brain
data.
works.
Okay.
Right. So if I see a list of numbers, I know it's going to be data. And if I see X bars, I know it's going to be stats. Right. Now, in this case here, let's see what the numbers are. It's data. We're going to do 20 for mu naught. That's going to stay put, that's going to stay put. And finally, we get to do a less than. And you see it's the middle one, the less than. And then I can hit calculate. And the guy that really matters is the p-value. And the p-value is 0.0, lost it, 35. Agreed? I have 0.035. Did I miss a data point? Are you getting the same stuff as me then? Right. If you don't get that one, you missed a data point then. You forgot to type in 21 or something, right? It happens. Okay, so that's 2 and 3 done. Oh, by the way, there's a lot of other data there. And do you see that they tell you the standard deviation of the sample is 3.4? See that again? I mean, it tells you stuff you don't directly need. Doesn't it tell you the mean is 17.1? See that? And it also tells you the p-value. and it also tells you what the t-score is, right? So this t-test is nice because it kind of tells you everything, even if you didn't want to know it. In the context of this question, isn't the most important thing what the p-value is? Right? It's nice to know the other stuff, but p-value is what I truly want. And so I can now do my conclusion. Is my p-value less than alpha? Well, is 0.035 less than 0.05? And would you agree the answer is a big fat yes? Agreed? And when it's a yes, we say all this stuff. Right. Agreed? Maybe you should get one of those ink pads with that sentence and you just go, right? That would be a cool idea. I'm going to do a couple of things with this one since it's the last one of this family to show you what I think is quite interesting. This significance level is 5% and this was a yes. Suppose I had decided that it was a 1%, right? Significance level, and I was going to use a 1%, right? A 0.01. Wouldn't this have been a no? So doesn't the significance level that you use influence whether you only say yes or no? In some cases, the p-value is so tiny it don't matter, right? It's always going to be yes. But isn't there going to be some situations where that p-value is a kind of grey area, and if you use one significance level, it's going to work, but if you use a different one, a more accurate significance level, then you might end up with a no. Can you see why there might be temptation to wait until you've seen the p-value before you decide what your significance level alpha was? And that's technically cheating. That's like looking in the box to see what's there before you decide what's there, right? What you're meant to do is, the data is meant to speak for itself. So if you're doing this analysis correctly, this hypothesis test, you would be choosing that number before you did any analysis. If you ever see a group of reports, right, 2 or 3, they're comparing, America to Canada, America to China, America to somewhere else, right? They're doing lots of comparisons like that. And they're saying statistically significant every single time. If you see the significance level is being changed each time, that is suspicious, because sounds to me like they're cherry picking the significance level that they want to have a statistically significant result.
Well, isn't that like the interval, right? So they're choosing it, a wider interval or a more narrow interval
to get the answer they're trying to find.
Answers. Okay.
That they want, or whatever way you want to phrase it. Now, I know why there's temptation to that. If it's not statistically significant, isn't that kind of not telling you much at all, if anything? It might be bigger, it might be less, nobody knows. That's kind of what you're saying. People don't like to spend a lot of money and time to come up with a conclusion at the end of the day that it's not statistically significant. Nobody's going to write a medical journal or go to the Lancet and say, I spent $500,000 doing this really, really big, clinical trial. And at the end, to tell you that there's nothing statistically significant different about the 2 ways of doing hip replacement. Right? One's not better or worse, we can't tell. Right? Or there is not statistically significant that one group of people will catch this disease more often than another group of people. Because one of the things that you are interested in, something say like COVID again, don't you want to know the risk factors in what's going to cause problems? As far as I know, and I could be wrong, but as far as I know, being old is a major risk factor. Most of you are very young compared to the people who tend to suffer badly with it. So if you were a 20-year-old, will you die of COVID? Yes, you will. Will you die very often with COVID? No, you won't. If you're 90, will you die of COVID? Yes, you probably will. Will you not die of it? Yeah, but the percentage who die is much higher. So what should you be doing? Well, what you should have been doing, but we kind of don't know that until the end, is shouldn't we have been protecting the old? So especially the old and infirm in special care housing. Shouldn't they have been chucking in the money there? Isolate, separate, test. For instance, wasn't the biggest death rate happening in old folks' homes in Washington State? Weren't some of the biggest death rates in New York also caused by old folks' homes? Because it just spread through like wildfire. They are already infirm, they are already a very high risk group, they already have preconditions. It's like a perfect storm. If COVID was wanting to go somewhere, that's where it would want to go its holidays, right? That's where it causes damage. What we shouldn't have been doing is doing lockdowns in those homes where the person next to you has it and you stay put. And you shouldn't have had in New York people who were tested for COVID and returned back to the same hospital or the same daycare centre, whatever you call it, as before. That's what we should have been doing. Now, did I know that at the time? No. Nobody knew at the time until they had enough data. At the beginning, you don't know what COVID's going to do, right? It could have went for kids. Thank goodness it doesn't. Do you know, kids are probably the safest group out there. Now, they might not be the safest group in the sense that they don't catch COVID. They probably do. I'm sure they do. But what makes them safe? Very few of them die of it. And there's lots of explanations I read. I don't know if they're true. Kids are like breeding Petri dishes. Don't they catch everything under the sun? The plus of that is that they have a huge immune system. It's very strong. So when they catch COVID, their body can handle it 9 times out of 10. Now, poor kids die, unfortunately. Poor kids die of the flu. Right? Things happen. But as a population group, they're very safe. I'm in a terrible place. I'm old. I have asthma. I have chronic bronchitis. And I'm definitely overweight, which are all the bad things for COVID. Marie, if I can be personal, you've got all the good stuff. You're young. You're definitely not overweight, right? I'm assuming that you don't have asthma or chronic bronchitis as I do.
I might have like an exercise-induced
Okay.
asthma, but that's, yeah.
Far from that. So, do you know, if people were trying to protect people, shouldn't they be protecting me and say, Marie, you're fine, just wear a mask? So, whatever. I got my little rant over. I'm happy. Are we cool with this process? Right. A couple of things I want to show you before I forget. I'm going to go back into that menu. And I'm just going to use the same data, so I'm not going to change it, right? So 20, L1, L2, less than. Do you see there a guy next to it called draw? When I hit that, it draws a pretty little picture to show you the p-value. Do you see the p-value is that little shaded guy to the left?
Mine says error on it. I don't know what I did.
Oh, I don't know what you did. I'll go back in and you can compare my data to yours.
Okay.
You didn't rub out L1 by any chance, did you? Did you get all those guys? Yeah. Check your L1 in case the data is missing. Maybe somehow it got deleted by accident. But if you've got that, it works fine. I can't hear you, Rachel.
I said I have all the data correctly input on it too. I'm just not
Okay,
sure.
Marie, you're. I can see your face, so you can nod quickly. And did that little picture appear if you did it? Right. I don't know what's wrong. I can't see it. But
Like,
yeah, right. The next time you do it, it'll probably work. You know.
Okay.
Are you using a TI-84 or a version of it?
Yeah, TI-84. It also has a color. It has a blue option, or it says like the type of color on it.
Oh, okay, that's nice.
So I don't know if that has anything to do with
No,
it.
it should. Oh, I doubt it. I doubt it.
Yeah.
Mine
Right.
says the same, and my drawing's working.
Okay, so just Rachel, her and technology are
Just
having
me.
a bad
I'm
day.
just the
right?
weird one. Doesn't work.
No, mine says error too. I
So
don't know why. mine
I
says
don't
error
know
too.
why. I'm confused.
It says check one dim list 99 to set plots off, and second plots off. Check dim matrix 99. Check
Oh,
inverse
God,
square
no,
matrix.
no.
I don't know.
It's telling you a whole lot of yuck. Right.
That.
Okay. That big sentence. I do not know why it's doing that.
I'll have to
Clear
just
out your
leave it.
data, start again, and call it good. And if all else fails, the picture is probably not the biggest problem because getting p-value is, right? So as
But
long
if
as you
there's a
get that, you'll be
question
fine.
that has a picture on it, it
I will show
it.
you. Yeah, I will show you that, how you will get around that. This is a drawback of virtual. If we were in class, I would just get your calculator and I'd say, ooh, that menu should have been disabled or something, right? I might be able to fix it that way. But right now, we're kind of, I don't know. Okay, so what I want to show you.
Are
Yes,
you going to take a screenshot?
I will. God, she's pushy, but not right now.
You said
'Cause-
to remind you.
Okay.
I didn't want to forget.
Okay, it's now, you've done your job, you've done your duty, right? Can I just show you an example of what this homework looks like, and then we'll move through this. So here is a story. This is a classic example of the kind of thing that we're doing. So let X be a random sample that represents the pH in arterial plasma. Oh, the acidity of your blood. The nursing people would be interested in that. For healthy adults, the mean is 7.4. And I think that's a little reference thing. So if you click on it, you can go and see where it came from. A new drug for arthritis has been developed. Why? Has arthritis something to do with the pH? If you've got a high pH, do you get arthritis? I don't know. Anyway, keep going. A new drug for arthritis has been developed. However, it is thought that this drug, it's a side effect that they're worried about. So this drug may change the pH. So we're going to create a random sample of 41 patients. In this case, do you see that the mean is 8.4, which is a bit high, right? It should be 7.4, right? But it's a bit high, it's 8.4. And that the sample standard deviation is 3.1, and that you're going to use an alpha of 5%. So do you see all the information in my story is kind of there, right? So what is the significance level? Well, the significance level is 5%, but you write it as a decimal. Okay, now one of these 5 guys represents the null and alternate. Now he's calling the alternate H1, I don't care. It's HA, it's the same thing, right? H naught, HA. Right, which one of these represents this story? He's concerned that, oh, wait a minute, let's find out. Test the claim that the drug has changed either way. Changed either way is a big clue to this.
Isn't that the equal sign with a slash through it? I forget what it's called.
Yeah, it's called not equals.
Not equal. Oh, there you
So
go.
I got this guy here. isn't the H naught nu is 77.4 and the alternate is nu is not 7.4. So that's how you would answer this question, right? Now it then goes on and it talks about what sampling distribution would you use. This would be much better if I was doing that by me saying which of the menus in your calculator would be the right one to get that data. So we're going to have to twist this a little bit. Is it going to be a T or a Z? Z, they're using the word norm. Is it a T or a Z that you use in this story?
T.
Because you don't know sigma. Now I've got a choice. Is it this T or is it that T?
First one.
And the reason it's the first one is because sigma is unknown. It's not this one. You don't use a T because sigma is known. Don't you use a T because sigma is unknown? So you would tick that choice. Now, the next chunk of questions all come from the calculator, including the pretty picture. So I'm going to have to leave this guy for a minute and go back in. And that's going to get you another chance, Rachel, and whoever the other person was, to see if we can make this pretty picture work, right? So I'm going to go in and we're going to use this data. And so clear that out of the way and clear that out of the way. And I'm going to go start. I'm going to do tests. Is it number 1 or 2 based on what we've just been talking about?
2.
2. Is it data or stats based on this information?
Stats.
And I'm going to hit this. Now, you can't see it anymore, but I can. So that guy there was 7.4. Agreed? The mean was 8.4. And the standard deviation of the sample was 3.1. And the number of people in this sample was 41. And we are looking for the not equals to version, right? So we're all comfortable about where all the numbers came from in the story, although I'm reading them out to you. They would be there when you're looking. Now, when I hit enter, we have got a whole load of stuff here. The test statistic that they're talking about isn't the p-value. It's actually the t-number, right? So when you have a box that says, what is the test statistic? You're going to write in 2.066 if you round it off. Now, keep that p-value in your head, 0.045, right? 0.045, because I'm going to have to leave here, 0.045, and show you how you're meant to write down your answers in the homework, because it doesn't quite write it the way I would, but that's fine. Remember we did these answers? There's that T statistic that we talked about. You know, that's where it goes there. Now, this is what I would have hoped. Shouldn't they have just said, what's the p-value and put a box and you type in that decimal, and that decimal is 0.045? I mean, that's how they should have asked it. Instead, it's one of these choices, but only one of them. So 0.045, where does that live?
Would it be between the 0.020 and the 0.5?
Yeah, agreed. Is it not where 4.5% lives? So that's what 0.045 is. So do you see in this case, you just click that? Right. Now, the picture that you should get is going to be this one. And I can tell, because isn't this a two-tailed test? And when it's a two-tailed test, don't you get a bit from each side? If it was a right-tailed test, wouldn't I pick this one, even if I couldn't get my picture? If it was a left-tailed test, I would pick this one, and I would never pick that one for any reason. Now I'm going to go back in, and we are going to try that picture. And you are going to say, it worked this time, right? And we are all going to say, I don't know what you did different. So Stats, move over to tests, down to number 2. Keep everything the same, go right to the end, but choose draw. And hit enter. No. Okay, go look at your manual and figure out what the heck's wrong.
Yeah, I
Because you
think
did
there's
get the
something.
T-score and all that stuff, right?
Right, I got all the T-score and everything, but I think there must be something. My daughter must have got a hold of it or something. And start
That can
pressing
happen.
buttons.
Right.
Yeah.
This is what you do if your calculator really goes weird on you. So let's spend a few moments just doing that. On your calculator, there's a kind of reset back to normal, right? Taking your batteries out and in sometimes can work, but a lot of things are stored permanently and it doesn't work very often. It might work for the weird, simple mistake. So let's show you how you, in fact, fix your calculator to back to factory defaults. Hit the blue button plus. It takes you to a thing called memory, right? So blue button plus, right? Second shift plus, whatever color yours is, right? Now, if we go down to number 7, reset, and you hit enter, you'll be able to reset all RAM. That's memory. So if there was something weird stored somewhere that your little daughter was just hitting random buttons and now there's a thing in the way, and that will take care of it. And factory defaults is number 2, which pretty much is, start as if you took it out of the box. So I'm going to choose 2 first, and you hit 2. And then it should say to you, are you really sure? Because it gives you one more chance to hit no and get out of there. But I am sure, so I'm picking number 2, and I'm hitting that, and it's default set. Okay, go back in and try and draw the picture. So here we go, stats, test, number 2, go all the way to the end.
It fixed it. Thank you. Because there
We
it
got
is.
our picture. Right, now there's somebody else had the same problem. I'm all I can say is I can't remember who you were. Have you tried the same
was
thing?
me.
Did it work?
Yes.
Right, but the good thing is that's your get out of jail free card when you try and do standard deviation and the thing just keels over and does a page full of errors, right?
Thank you for that.
Right. The other thing is you hide your stuff from your kids, right?
She's really sneaky though. She likes.
Oh.
She has autism, and so she's really sneaky.
Okay. Well, give it to her and let her play with it, but reset every time before you start class. How about that as a workaround, right? I don't want to deprive her if she likes it. Yeah. There's just some technology is kind of fun, so I can understand. Are we cool with the general process of what your homework's going to look like? There's going to be a story, and it's going to be sigma known or sigma unknown, and the answers or the questions look almost exactly the same as the ones I've just did. Right, a couple at the beginning are kind of warm-ups, but that is it. And that kind of gets us to the end of 8.2, and I want to get started on 8.3, right? And 8.3 is also hypothesis testing, but it's hypothesis testing of proportions, right? So we just finished hypothesis testing of a single mean. Now we're going to do 8.3. Hypothesis testing of proportions. So there's going to be a story attached to these guys, right? So let's start with my first story. In the past, % of Americans, 0.02, were vegetarians. making the number up. I've forgotten the name. What do you call the scientist who does dietary things?
Dietitian.
Dietitian, right? A hospital dietitian believes that that has increased, right? So they're working at maybe a medical university, right, where you get money and time to do research as well as your normal job. And she want to find out if this is true, right? Have Americans became more vegetarian, right? So at a significance level of 5%, she goes out and she finds 1,000 people, and she discovers that 27 of them are vegetarians, right? Full-time vegetarians, not I sometimes eat chicken, right? It's full-time vegetarians, right? And whatever. That is all you need. And we should be able to find out, is that statistically significant? Right, now if I turn this guy into a decimal, can you see that it is bigger, right? So she wants to know, is it possible to prove that the percentage of Americans who are vegetarians today is more than it used to be in the past? So H naught, P equals 0.02. Do you see we now use P, not mu? We're not talking about the population proportion, P. Great. And then we're going to get the alternate. And in this story, don't we think it's increased? So this would be a right-tailed test. And we could do all the calculations, but we're not. We're going to get the calculator to do it all for us. So I'm going to hit start. I'm going to go over to tests. And now I have to find which test to use. It's on that screen. Which one is it?
5.
Yes. It's a one proportion, because there's only one sample. Z test. And you might think, but I don't know sigma. Sigma is only for means. If sigma is known, it's a Z score. If sigma is unknown, it's a T score. Proportions don't use T distributions at all. Proportions, just because the way proportions work, they're binomial functions, always work with Z scores, which is kind of nice. So I'm hitting number 1 and we're done. Do you notice that we don't even have a menu choice, data or statistics? Do you see when you do proportions, it's the same story, right? So what do I know? I know that P naught is 2%. That's what it was in the past. This top number is essentially X. So 27 people out of 1,000. So far, so good. Now, which one of the 3 choices are we looking at? Well, aren't we looking for the third one, the greater than guy? And now I'll scroll down to calculate. And you see that we get lots of things, but the only thing that really matters as far as this goes is that the p-value is 0.027. So let's do the conclusion then. Is our p-value less than alpha? Is 0.027 less than 0.05? And the answer is a big yes. To which I am not even going to bother getting the piece of paper now. In here, won't you say this is statistically significant? And then do the bit about there's enough evidence to reject H naught and so HA is true. And I know you don't do that in any of your homework, but it's good math to just realize that's what you would do in a physical world if you were writing it down. So does it not mean then that there are more vegetarians today than there was in the past? We go with that, guy?
I have a question.
Yes.
So we write the p hat value then?
Yes.
Okay.
Oh, what do you mean p hat? We don't write the p hat value in.
Because p hat, I got 0.027, and then for
Yeah. Look at what I've got here.
Zero.
I'll go back in. Maybe I was too quick. You do not use the p hat. Let me show you what you use. You use p naught. This guy up here. This is the guy that goes into your calculator. Not this guy, but this one. Right?
Yeah.
Right.
So-
Now if you do that, now what happens? The 27 over 1,000, I guess that is the p hat, isn't the 27 the top and the thousands the bottom? So that's kind of where the p hat is. It's not a single value, isn't it? The top number and the bottom number. Yes, no, Doris?
Okay, and I
Okay.
asked for when you hit calculate,
Uh-huh.
there's like a p hat and then a p. I think we wrote down p hat for our,
Oh, I did. Darn it in space and things that aren't nice. Can I show you what I did? If you look really carefully, do you see that there's a P and then underneath it's a P hat? And I think I wrote down the wrong guy. The P is 0.057 if you round it off. Do you see the P? Oops. You see the P? Right. When I look at it, because I haven't got great eyesight, do you notice that the P hat almost looks like a P? And so when I was scanning, I just thought it said P. That's where my mistake is. So let's pretend that I hadn't done that mistake. Well caught, Doris. There is the P, right? The P value. That's the guy we use. Now, is our P value 0.057? Is it less than this guy? Ah, different conclusion now, isn't it? No. So this is not statistically significant. And when it's not statistically significant, we write down there is not enough evidence to reject H0. Now, the good thing about proportion questions is that there's only one version of them. This version, right? There isn't a sigma known, sigma unknown, data and statistics, right? Like we had the last time, right? 4 flavors. In these questions, they're all the same basic question, right? You have a percentage, right? You do a sample. Hopefully you write it down this way, you have a significance level, and off you go. Okay, I'll try the next one a bit more careful. Have we got, maybe got time? I think we've got time to make this more fun, so I'm going to pick something and just ask us. Okay, and so that Marie doesn't give me a hard time, I am now about to do a screen grab. And we are good. And now I'm going to go back to our story. Right, okay, I need a story here. So 2, 5, 10, 15, 20, either 25. Oops, Okay, there's 25 of us. In Scotland, %80 of Scottish people went out to the pub in the last week. Right? And a pub is any place you go to where alcohol is served. So you're not allowed to pretend that a casino is not a pub. And you're not allowed to a restaurant where alcohol is being served. So I'm calling it a pub, but maybe I should phrase it. Went to a place where alcohol was served. Okay? And this person thinks that Americans don't do that quite as often, or maybe do it more. We'll find out in a second. Makes it different, right? They think it's different. Okay. Okay, head count. How many of you have been to a place where alcohol has been served as a choice, whether you drank some or not? 2, 4, 1, 2, 3, 4, 5, 6, 7, 8, and me makes 9. There we go. So we are going to look at, is it true or is it statistically provable that Americans don't go to places that serve alcohol quite as much as we do in Scotland? So let's find out. Won't P be 0.8? And won't the alternate be? And when I started, didn't I say it was different? I can tell now that it's bigger, or less, I should say. But when I started the story, I just made the assumption that Americans did it differently, right? More or less, I couldn't say for sure. That's why that's a two-tailed, right? Now, at this point, we are ready to go calculator hunting. So, put a stats in. Go down to choice 5. 0.8 is Scots people. 9 out of 25 is American. And then don't you just choose the right one? Would you agree in a lot of ways, aren't this question cleaner and tidier? You just need to know what the number was in the old, and don't you need to know the top and bottom number of P hat and, you know, left, right, or two-sided? And then I'll hit calculate. And, oh, that's a good p-value. You agree that's a tiny, tiny p-value? The calculator says roughly 3.8 e to the negative 8, which we know means that, which we know is that. There should be 8 zeros before you hit the first digit that's not 0. In this case then, is the p-value less than alpha? Well, is all those zeros less than this guy? The answer is yes. Isn't this statistically significant that Americans don't go to places that sell alcohol as often as Scottish people would do? There is probably a lot of truth in that. The stereotype about Scots and Irish, they're very similar in that respect. They drink far too much. I am talking far too much. They do. I am a very bad Scotsman. I don't get drunk very often. A couple of times a year, perhaps. Hogmanay and my birthday, probably. I don't start fights, and I don't want to invade anywhere. So I'm a pretty boring Scotsman. Now, on the other hand, a lot of Irish drink far too much, want to start fights everywhere. Probably they don't want to invade anywhere. They're not up to that, but they're 2 out of the 3 would be true. True story. I had a friend back in Scotland. His nickname was Fra, his real name was Francis, but they just called him Fra, F-R-A, right? And he was a really nice guy. I mean, when this guy was sober, he was a hilarious guy. He was really a pleasure to be with, right? It was fun. But he was a mean drunk. You know, some drunks are just mean. And whenever he got drunk, he wanted to start fights. He would deliberately try and antagonize you, you know, to try and get you to fight him, right? But all his friends, you know, I was considered one of them. We knew what he was like, so we never fell for the bait. We just said, "You're right." He could say anything about us. "You're right." "Oh God, yeah, I'm far too fat." "You're right, I'm really fat." "Oh God, you're clever realizing that." You know, drives them crazy, right? He couldn't get a fight out of us. It didn't save him, because he would just go and pick a fight with someone, and not everyone was as generous as we were to him, right? He would insult them until he got into a fight. The problem was he was only about 5 foot, and he was a horrible fighter, especially when he was drunk. So I don't think he ever won any fights. He just got beat up a lot. And I told him once, I said to him, "Look, Fra, maybe you shouldn't drink, or at least drink to excess. It's not healthy for you." You know, he would get beat up and he had black eyes all the time. And he went and said, "I like drinking." And I never got that thought process. I was always thinking that part of your brain would say cause and effect. I get drunk, I start fights, I get beat up. I got drunk, started that process. If I didn't get drunk, the other two didn't happen. Cause and effect. Now, he used to, for instance, every time he got drunk, he would come in the next day while he was sober, and he would go to various people and say, "Should I be apologizing to you?" Because, you know, and so he would go around us and he would say, "Donald, should I have apologized to you?" And I said, "Yeah, you should have apologized, but yeah, what the heck." I don't know why he does that. I don't know, maybe he was a sad person inside, or he had an issue and he couldn't handle it, whatever. You can tell I'm still homesick. I was homesick yesterday. I think I gave my class about 3 different stories about Scotland. And since we're going to finish in about 4 minutes, I'm going to tell you one more. My wife lived in Scotland. She immigrated to Scotland when we first got married, and my wife got to experience Hogmanay for sure, which was fun. But she also got to experience Halloween. And if you know anything about Halloween, you would expect that because we're, you know, America and Britain have a lot of shared history, that Halloween would probably be very similar. And it is. The kids all dress up as, you know, pirates and princesses, and they come round your door, and their parents or their big sister or brother is with them, and you give them candy. All of that is exactly the same, right? But there are differences when you come to. Did I tell you this? Was that my night class? No. So they come to the door, but in Scotland, I think it's because our weather is pretty bad round about that time, that very often what happens is when they come to your door, they come into your house. So they come into your house and you give them the candy. It gets them out of the bad weather for a little while. And secondly, you have to do something before you get your candy. So the kids have got to do something, right? And they know that as part of their routine. So they'll tell you bad jokes, right? Hence of where I got my material. You know the little girls, the tweenies, whoever the favourite pop song is, they like to go with each other, little groups of 3, and they're all dressed as princesses or whatever, and they sing the latest song really badly and they forget half the words, and it's really fun. And the 3-year-olds, the tiny little ones, do the ballet. I'm going to just close that off for a second. There we go. So the tiny ones do the ballet. Do you know how you do the ballet when you're 3? You get your little legs and you go tap, 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 tap. And then you all burst into applause and they love it, right? And my wife thought that was really cool. That different way of doing it. And it was brilliant. And I thought it was brilliant too, and I missed that. And anyway, eventually we came back to America, and we got to do Halloween in America. And you got to think from my brain, my perspective, what Halloween should be like, right? So I got the give out the candy job. I thought, okay, I can do that. And the first knock on the door, and I opened the door, and there's like 3 kids and somebody's parents behind them. And I'm looking at them. And they're looking back at me. And I'm confused. They're not wanting to come in the house. And my wife says, what's up? And I says, they're not doing anything. And she says, what do you mean they're not doing anything? They're not doing anything. They're just standing there. And then I thought, well, I said, do something. I said, sing, tell me a joke, do something. And my wife like, oh God, no. She suddenly realized, I did not realize that that's not what you did. So you see that culture shock of, you can be doing something totally innocent, because from your culture, that's what you do. But people will say, weirdo wants the kids in my house and asks them to dance. So try and be a little bit more culturally sensitive to some other cultures. So, I'm making this up, but I can imagine at Halloween, if you were an Asian person and you've just arrived this year and Halloween is a total mystery to you, what it might look like when parents and kids dressed up funny come to your door and want free candy from you. Can you just imagine how your brain would be? What the heck is going on here? Right? And so everyone's got this, what we do the same and what we do differently. In Scotland, Hogmanay, which is the 31st to the 1st, is a huge holiday for adults. 90% of Scotland probably gets drunk, except the 10% who are teetotal. And one of the things you do in Scotland, if you're young at least, is that you go and you visit parties. And you visit parties of people you don't even know. The only rules is you bring a bag with alcohol in it, so you're not drinking theirs, and you go to the door and you just knock on the door. If there's a party going on inside, they'll let you in. You just turn up. Not a biggie. I think that wouldn't go down well if there was a party in America at Hogmanay and a total stranger knocks on the door and wants to join in. The culture's difference, right? What is expected is not always the same. You think you're living in the same world. My wife used to say it was like Twilight Zone. You think you're in the same world, and then they go and do something that's not normal. Now, I haven't found any American cultures that are weird to me. I can live with them all now that I've learnt them. But you can imagine how hard it might have been for my first year, where I'm always thinking, got to be careful. They might not do it this way in America, right? Don't invite kids into your house. Got that one. Not doing it anymore, right? Don't ask them to dance. Doesn't happen in America, right? Ain't going to happen anymore, right? Okay, that was fun. I enjoyed that. That was a cheery moment for me. Oh, no, guys, got one more. Do you know people come to your door with drink? And that's common. And in my family, because it was huge, a lot of the people who came were actually my relatives. So our house was like stowed. So strangers turned up and just joined in. It was great fun. We stayed in a house that used to be owned by a different person. He moved from this house and he went to a larger house that was like 12 doors up. I think it was his used to be his mother's house, and he moved to that house. And we were there, and this was one Hogmanay, and it was a very quiet time. All my family had left by then, and it was just me and my brother were still awake, and we were watching TV or something. and there was a knock on the door, and this guy was at the door. And he was the guy who used to live in our house. And I thought, oh, well, he just coming in for Hogmanay, and that was fine. But it wasn't fine. He got so drunk he'd forgotten where he lived, and he thought we were living in his house. He thought, I guess we'd broken in and decided just to stay there. And there was a fair amount of altercations going on because he wanted to fight. You know, you've broken into my house, you know, come on now, I'm going to take you on. And anyway, we didn't fight because drunks are notoriously bad at fighting. Do you know if you keep moving, they can't catch you, right? So you're safe. Basically, don't let one grab you. That would be the only thing. So anyway, we were doing this dance outside where he was trying to fight me, and finally we settled him down and said, well, come on, I'll take you to a better party. And oh, the word party got him going. So off he went, and I took him to his own house because I knew where he lived. And I knocked on the door, and his wife opened the door, and I said, he's yours. And I ran. And that was it. So he came by the next morning. I'm sure his wife told him, and he had to apologize profusely about what had happened. It just shows you that if you get really drunk, your brain doesn't always function 100%. And the fact that he had moved house somehow get lost in the fog of alcohol. So if you ever go to Scotland, I wouldn't do it if it were a girl. To be honest, I wouldn't do it if you were a girl. But if you're a guy, or a guy with a girl, or something like that, have a bag of alcohol, visit some parties. Be kind of fun. Right, we're definitely going. Bye-bye, everybody. I'll hang about if there's any questions. I think I've got some chat, but people are just time.
I have a question.
Okay. Before you get to a question, answering some of the ones, some of you have had issues with your homework, not having enough time. I'm assuming you're talking about last week's homework. And that's already been extended. So if you go and look, it should be okay. You've got until Wednesday to do that, if that was your question. So I think 2 people who said that. So if it's not, will you check with me again and I'll double check, but I'm 90% sure that it's due on the 5th, which is tomorrow midnight. So you have an extension to that. Don't let it get too much ahead of you because we've one set of homework, which is due on Monday. Right, all this stuff, and if you spend all your time doing the stuff you're behind, you're going to be behind on this stuff because you haven't had time to do that. So keep that in mind. Okay. Any other questions? Oh, you had one, Jenny, or whoever's first. Jenny?
Okay. My question was, when we were doing when you were talking about the lecture yesterday.
Oh, by the way, that lecture died. It never made it, sorry.
Okay.
I do have a copy of the night one, and it's weird, but at least it's saved. This one I think works. I had to go into Zoom and figure out what the heck was going on. It just disappeared in the ether. I thought I had it. Evidently I didn't. So anyway, you're saying yesterday I was talking about?
Yeah, and it was basically, I was doing the homework and I was thinking about what your lecture was, and I was thinking about the stage when we're computing the Z value.
Right.
And it is the X bar minus mu over
standard error.
And with the square root of n.
Yeah. Well, yeah, sigma over root n, which is what the standard error is, yeah.
Now, this is just where I was just getting lost and thinking, why do we use that way of finding Z-score? Aren't there other ways of finding it?
The Z-score in general is data take away mean over standard deviation. That would be a generic version of it. In this case, your data is X bar. The mean is the mu. And the standard deviation that we're using is the sampling distributions standard deviation. And the reason we're using that one is because this is a sample and we're trying to find how likely this sample is to happen. So when you're losing a sampling distribution, it's always the standard error, and the standard error, which is just another name for the standard deviation of the sampling distribution, right? The standard error is the sigma over root n gain. And that's why we use that. If this question had nothing to do with hypothesis testing and it was you pick one person from a population, what's the chances he's bigger than or less than this number, then the bottom would just be the usual sigma.
Okay.
But this is a sample, in which case it's a standard error.
It was the kind of thing where when I was doing it, I actually got the right answers on the homework, but I felt like I just didn't understand why I was doing it that way.
Okay, has it helped? I think Marie
Yes.
probably had that same conceptual thing. It's because we're dealing with a sample. The data isn't one number, it's actually 20 numbers averaged out, right? It's a sample that we're using. And because of that, the standard deviation of the sampling distribution